Today, I'm going to be talking about how activated carbon filters work. So, what is activated carbon? Well, activated carbon is a special form of carbon that's used to filter water and air. It's created through a process called activation, where carbon-rich materials like wood, coal, or coconut shells are heated to very high temperatures. This is done without oxygen in a process known as pyrolysis, which prevents the material from burning. What's left behind is a porous, charcoal-like substance with an incredibly large surface area. Activated carbon is sometimes called activated charcoal, and it's one of the most common and effective materials used for purification. One of the most important things about activated carbon is its surface area. Imagine a single gram of it having a surface area as big as several tennis courts. This happens because the activation process creates thousands of tiny holes or pores inside the carbon. These pores can give the carbon more space to trap unwanted materials. Just 2 or 3 grams of activated carbon can have the surface area of an entire football field, and that's why it works so well. The more surface area, the more places contaminants can stick. Activated carbon doesn't soak things up like a sponge. This is a common misconception. Instead, it uses a process called adsorption. That's adsorption with a D, not absorption. In adsorption, contaminants stick to the surface of the carbon rather than getting absorbed inside it. These contaminants are held in place by van der Waals forces, which are relatively weak electric forces that attract neutral molecules to each other, and sometimes even chemical bonding. The larger the surface area, the more contaminants the carbon can adsorb. This is what makes it so effective at cleaning up water. Activated carbon is especially good at removing certain types of contaminants from water. For example, it can remove chlorine, which is added to water for disinfection, but can give it a bad taste or smell. It also removes volatile organic compounds, or VOCs, which are chemicals that can come from industrial pollution. Some heavy metals can be trapped too, depending on the filter design. And of course, it's great at eliminating odors and discoloration. That's why filtered water usually looks and tastes cleaner. However, activated carbon has its limits. It can't remove everything from water. It's not effective against salts or minerals that cause hard water, things like calcium and magnesium. It also doesn't remove viruses or most bacteria unless the filter is combined with another method like UV light or a membrane filter. That's why some advanced filtration systems use multiple stages to handle different types of contaminants. Activated carbon is powerful, but it's just one piece of the puzzle. The production of activated carbon can happen in 2 main ways. The first is physical activation. After carbonization, the material is exposed to high temperature steam or carbon dioxide, which opens up the internal pores. The second method is chemical activation, where the raw material is soaked in a chemical like phosphoric acid or potassium hydroxide before heating. This method often creates even more pores and is used when precise control over the pore structure is needed. Both processes are designed to maximize surface area and create a very porous, lightweight substance. Activated carbon is found in all sorts of water purification products. It's in pitcher filters like Brita, under sink filters, faucet-mounted systems, and even some whole house systems. It's also used in aquariums to keep water safe for fish, and in air purifiers to trap odors and chemicals. Industrially, it's used in wastewater treatment, gas purification, and even in medical applications like poison treatment. Its versatility makes it a go-to solution wherever filtration is needed. Like any filter, activated carbon has a limited lifespan. Over time, the pores fill up with trapped contaminants and the filter becomes less effective. If you don't replace it on time, the carbon can start releasing what it trapped, kind of like a sponge dripping water. Worse, it can become a place for bacteria to grow. That's why manufacturers recommend replacing your filters every few months depending on the usage. Keeping your filter fresh is key to keeping your water clean. You can perform an experiment to test water filters to see which material, granular or powdered activated carbon, filters better. To do this experiment, you'll first prepare several simple filters using the top halves of plastic bottles lined with coffee filters or paper towels. Into each one, add a different material: powdered activated carbon, granular activated carbon, and a control group with nothing added. Then pour the same amount of dirty water, made by mixing tap water with things like soil or food coloring, into each filter. As the water passes through, collect it in a cup underneath. Finally, compare the filtered water from each setup by checking how clear it looks, how it smells, and how fast it filtered. This will help you figure out which material works best for cleaning water. In my experiment, granular activated carbon was able to filter water faster, but the powdered activated carbon removed more of the coloring. So to wrap it all up, activated carbon is a super porous form of carbon made by heating organic materials without oxygen. Its high surface area allows it to remove many impurities through a process called adsorption. It's especially good at getting rid of chlorine, odors, and some chemicals, though it doesn't remove everything. That's why it's often combined with other filtering methods. You can find activated carbon in filters everywhere, from your kitchen to massive water treatment plants. It's a simple but powerful way to make water safer and better tasting.